Welcome to the Deep Dive. Today we're cutting through some serious noise to look at a really fundamental question about where we're headed digitally. We keep hearing about this amazing future, right? Super smart AI, instant digital cash. But the source material we've been digging into, it kind of throws down a challenge. It asks, what if the very foundations we're building right now? What if they're actually designed for scarcity, for high fees and, well, for surveillance?
It's a conversation we really have to have.
Yeah.
Because, as the sources point out pretty clearly, the technical choices, the architecture we pick now, that really dictates how things are governed later on, the economics of it all.
That's a big claim, though. Architecture is destiny, basically. So our mission for this deep dive is to unpack a very specific, maybe even provocative idea from our source material, which is that the convergence of AI and specifically Bitcoin SV, BSV, is the only missing piece needed to make digital trust actually work at a huge global scale.
Yeah, and we need to really scrutinize why. Why this specific blockchain, the one built for, well, basically unlimited scaling and super low costs, why is it being positioned as the only foundation for AI that's actually accountable and for giving individuals real digital sovereignty?
Right. So we'll look at the technical speeds they're claiming, which are pretty mind-blowing. We'll get into these cryptographic frameworks that they say can force artificial honesty onto AI. Sounds weird, but we'll unpack it.
Sure.
And we'll look at how these tiny fractional penny transactions are apparently changing whole industries already. Stuff like music royalties, even global finance. So yeah, let's get into it. Okay, let's kick off with the problem everyone in the blockchain space knows about, the one that's held things back for, what, a decade? Scaling. If your decentralized system can't handle real-world traffic in AO, I mean, if it's stuck at like 7 transactions a second for the whole planet, that creates what the sources call artificial scarcity. You basically have to limit use, and that costs people money, structurally.
Exactly. If that base layer is choked, everything built on top just gets expensive and clunky. The argument in the material is that if you want real digital abundance, you need a foundation that can handle utility-level scale. And that brings us to this thing called Terranode, which is part of the Bitcoin SV setup.
Okay, for listeners who haven't maybe tracked that specific project, what's the key difference in Terranode? How does it achieve that huge throughput they talk about?
Well, the big breakthrough with Terranode is getting away from the old idea that one giant server has to do everything. It uses a model where tasks are split up: validation, transaction processing, storing data. They're all handled by different specialized services. It lets the network scale out horizontally, kind of like how cloud services work. And that's how they managed to hit, in testing, an incredible 3 million transactions per second.
Wow, okay, 3 million TPS. That puts it up there with, like, Visa or MasterCard, the fastest centralized systems. But speed isn't everything if it costs a fortune, right? Especially for AI, you mentioned maybe millions of tiny transactions just for one task.
That's the absolute key point. The costs. We're talking tiny fractions of a penny, sometimes down to like 0.0001 per transaction, usually well under a cent. And that cost structure is what suddenly makes things like automated real-time micropayments viable. Between millions of devices or AI agents talking to each other, it just wasn't practical before.
And this cost thing, it really shines a light on the sort of philosophical split in the whole crypto world, doesn't it?
It really does. You've got this choice for abundance versus deliberate limitations. The sources highlight how the 1 megabyte block size cap on Bitcoin BTC, the original one, was an artificial choice. And it directly leads to those crazy high fees, $50, sometimes more, and network congestion. It basically enforces scarcity.
And the cost for just storing data is wildly different, too, based on the sources.
Oh, unbelievably different. They cite storing data on something like Ethereum at roughly $1 million per gigabyte because of how it's structured. On BSV, because they committed to letting blocks grow and focusing on efficiency, the same gigabyte costs under 50 cents.
$1 million versus 50 cents.
Yeah. That massive gap is what makes data-heavy stuff, like training big AI models, actually feasible on-chain.
Okay, those numbers are definitely jaw-dropping. But hang on. Usually when things scale up that much, they get more centralized, right? You need massive, expensive computers to participate. How does BSV avoid that while hitting 3 million transactions?
Right, that's where SPV comes in, simplified payment verification. It's absolutely crucial. SPV lets users, even small devices, securely check transactions without needing the whole massive ledger, which is terabytes now.
How does that actually work then?
Well, every transaction verification uses these things called Merkle proofs. It's basically a cryptographic fingerprint that connects your transaction directly and mathematically back to the summary in the block header. So the whole system's security comes from the huge processing power confirming the blocks, yeah? But you, the user or your phone or your smart sensor, you only need to check the relevant block header. And that's tiny, like 80 megabytes of data. SPV basically democratizes security, makes it accessible without needing a data center in your basement.
Okay, let's pivot a bit from just the raw speed and cost to trust. It's still a huge issue. We still pay what the sources call the trust tax. The 3% to 7% banks skim off international transfers just because the systems aren't inherently trustworthy. And digital identity is still this mess where you either give up all your privacy or you can't prove who you are.
And the solution being put forward in this material is trying to technically enforce trust, using something they call anchored intelligence, which is often discussed alongside this concept of a Merkle automaton. The goal really is to program, well, artificial honesty into how an AI makes decisions, step by step.
Artificial honesty. That sounds like a contradiction in terms. I mean, aren't AI models like GPT designed to generate plausible text? Even if it's not strictly true, they hallucinate, right?
Yeah.
How can a database structure force truth onto something probabilistic?
Yeah, that's the interesting part. The key is shifting focus. It's less about controlling the AI's final probabilistic output and more about making its inputs and its process completely verifiable. Think of the Merkle automaton as a model that uses the blockchain structure, these Muckle trees, to force a chain of checkable states. So knowledge gets broken down. You have the data itself. You have its full history, who made it, where, when, and you have its cryptographic hash, all linked together. This creates, as one source puts it, memory that is etched, verbatim, immutable.
Okay, so the memory isn't just stored somewhere. It's mathematically linked and auditable.
Precisely. And this creates an obligation. The system makes the AI cite its sources, trace its steps, anchor every claim it makes. So the AI stops being this kind of mystical black box and becomes more like a super meticulous librarian, one that has to show its work mathematically with proof anchored on the blockchain.
But what about sensitive data? If AI is using, say, private medical records or financial data as input, how do you maintain that kind of hardcore accountability without splashing the raw data all over a public ledger?
Right, critical question. This is what they term off-chain data, on-chain accountability. Let's take securing something called Model Context Protocol servers, or MCP servers.
Okay, hold on. Before we jump to MCP, maybe quickly explain what that is. Why are those servers so important to secure?
Good point. MCP is basically the rulebook. It defines the framework for how an AI model gets its input data and its operating instructions. Securing them is vital because that's where the AI's behavior is set. Now, the sensitive stuff, your actual medical data, say, stays private, off-chain, under your control. But when the AI accesses that data or uses a specific rule from the MCP server, it writes a cryptographic commitment onto the blockchain. Think of it like a secure fingerprint of that access record.
I see. So the blockchain doesn't hold the sensitive data itself, just the immutable, auditable receipt that the access happened and according to which rules.
Exactly right. You get permanent verifiable proof. What rules were followed, when it happened, who okayed it, all without compromising the underlying privacy. It makes AI decisions auditable after the fact.
And the same philosophy, it seems, completely flips how we handle digital identity, too. Puts the control back with the user, not the platform.
That's definitely the aim of what's called wallet-centric authentication. The main standard people talk about here is BRC-100.
BRC-100, just another technical standard.
Well, yeah, it's a technical standard, sort of like token standards on other chains, but this one defines how the identity keys stored securely in your wallet talk to apps. The whole script gets flipped. Instead of you logging into the app has to ask permission from your wallet to interact with you. You become the center of your own identity universe, not the platform.
Okay, and the key privacy piece here is selective disclosure, right?
Absolutely fundamental. You can use these cryptographic proofs. Zero-knowledge proofs are often involved to prove specific facts about yourself. Like, you can prove you're over 18 without showing your birthday, or prove you have a valid license without revealing the license number itself. You only disclose the absolute minimum required proof for that interaction.
Okay, let's bring this down to earth a bit. The economic impact. You have this kind of scale, these tiny fees, these proofs. It must be enabling completely new business models, right?
Yeah.
Where are we seeing that happen?
Yeah, the clearest examples are in industries that have always been bogged down by high friction, lots of middlemen. Take creative industries, music royalties, for example. There's a platform mentioned, Sonic AI. They're trying to fix the absolute nightmare that is royalty distribution.
Yeah, that system is legendarily slow and opaque and expensive.
So Sonic AI uses AI sonic fingerprinting to spot when a piece of music is used, apparently in under 300 milliseconds, like almost instantly. And because the BSV network can handle tiny fractional penny payments instantly, they can distribute those micropayments immediately, potentially to hundreds, maybe thousands of different people who own tiny fractions of the rights, all happening in real time.
Wow. Instant payout to potentially thousands of stakeholders for just one listen.
Yeah.
That basically cuts out all the old collection societies and their fees.
And it's possible because these aren't just simple payments. They're using the programmability of Bitcoin, the script language, to embed these complex rules, these automated contracts, right onto the base layer itself.
Okay, now let's swing to the other end of the spectrum. High finance, global derivatives. How does this kind of scale and programmability apply there? That's like the definition of high stakes.
Well, you have companies like Tokenovate. They're using BSV specifically to automate these incredibly complex financial contracts in the derivatives market, which is enormous, like $1.2 quadrillion. The efficiency claims are, well, they're pretty staggering. The aha step the sources use really drives it home. They claim a fairly small amount of BSV, purchasing 200 BSV, could be enough infrastructure capacity to process up to 1 billion trades.
1 billion trades.
Yeah.
Let's just process that. You're taking Wall Street complexity, stuff that needs huge server farms and armies of people, and running it on what's essentially public internet infrastructure for a fixed tiny cost per transaction.
And crucially, they're not just doing this in a vacuum. Tokenovate is working directly with ISDA, the International Swaps and Derivatives Association. That's the main industry body. They're automating standard workflows like interest rate resets. It shows this tech can meet the very strict demands of these huge regulated markets.
Okay, let's bring it back to the consumer experience. Social media. Usually it's all ads and your posts disappear into the ether. How does this infrastructure change that game?
There's an example, TreeChat.ai. It ditches the ad model completely. Instead, users can directly upvalue content they like with tiny micropayments, sort of like a micro tip. But maybe the bigger shift is permanence. Because the data gets written to this scalable blockchain, it's not locked into the platform servers. So when an older platform called Twetch shut down, TreeChat was apparently able to just resurrect those old conversations and display them, because the underlying data was still there on the public ledger.
Huh. That's a pretty powerful demonstration of owning your own data. It's not just on the platform, it actually belongs to you, immutably.
It really is. And one last piece maybe we should touch on quickly is just building this stuff. If the tech is so specialized, who's actually creating these apps?
Yeah, the learning curve must be pretty steep, right?
Well, the sources talk about something called vibe coding. The idea is using specialized AI assistance AI that's been trained specifically on the BSV documentation, the architecture, the code examples. These AI assistants handle a lot of the complex coding details, so it dramatically lowers the barrier to entry. Someone who's an expert in, say, finance or music rights but isn't a hardcore coder can potentially go from idea to a working prototype much faster, like hours or days instead of months. It lets domain experts build, shifting focus from syntax to just the vision. Hashtag tag outro.
Okay, so wrapping this up. This deep dive seems to show pretty clearly that AI, especially accountable AI, needs a very specific kind of infrastructure. It has to be predictable, it needs to be mathematically verifiable, and it has to be incredibly cheap to operate at scale. And the sources we looked at make a really strong case that BSV's architecture, the Terranode scale, those subsyn fees, the programmability with script, that this combination is uniquely suited to enable their vision of accountable AI and individual digital sovereignty.
And that really brings us right back to the core choice the source material lays out. We're building this digital future right now, and the technical choices we make today are effectively encoding the rules for tomorrow. One path, they argue, leads towards more centralized control. Think government-mandated digital IDs tracking everything, central bank digital currencies, AI acting as black boxes serving existing power structures.
And the alternative path presented is one of digital sovereignty, where you, the individual, own your identity through these verifiable credentials, where value transfer is stable, cheap, and doesn't need permission, and where AI systems are transparent, auditable, provably honest through math.
Yeah, the point is these architectures aren't neutral. They have politics, they have economics baked right in. The infrastructure that ultimately wins out will define the kind of digital world we live in. So the question the sources leave the learner with, is, are we going to build on systems designed for freedom, for abundance? Or are we going to stick with systems that seem structurally geared towards surveillance and scarcity? According to this material, the tools for that alternative path are ready. Now it's about choosing which future we actually want to build with them.